All right, in this section, we'll be looking at how to solve DE contextually. Okay, in fact, DE is one of the most useful mathematical model that can be used to solve many applications in physics, in engineering, population study, etc. Okay, and you will notice that most of the exam question for DE will be contextual. Now, so let's look at example 7 together. Okay, you are told that the current I in an electric circuit at the time t satisfy the following dE. Okay, and then you are asked to find I in terms of t given this condition. Now, if you take away all the context, it's simply just solving a dE, writing your solution with I in terms of t and substituting a condition that is given to you so that you get a particular solution. Okay, so sometimes the context is there just to add in a layer of application. It doesn't really make the question totally new or impossible to solve. Okay, so do not fear, just solve it as you have learned earlier. Okay, so what we have learned earlier is that if we have this dE, we will try to put everything that is I on one side and everything that is t on the other, and then we integrate both sides, right? So this is what we call the variable separable. So in my case, I will keep all the i's on the left hand side, okay, and in this case I kept my 1 on the right hand side with the t. Okay, and integrating both sides, I'm sure this integration I can leave it to you because this is technique of integration. If you realize you're struggling with techniques of integration, do go back to revise the earlier chapter, because we mentioned before, without the foundation of technique of integration, you're going to struggle for DE. Okay, now so suppose once I'm done, okay, with the integration, I'll get to this step. Now what I'm going to do next is that remember the question actually needs me to make I the subject. So it involved me trying to rearrange this expression. Of course, the fastest way is to first multiply by negative 3 over 4 on both sides to get this. Now instead of writing negative 3 over 4c, I can just replace it with an arbitrary constant called c prime, okay, or d, just something else that is not c anymore. All right, and then of course the next I'm gonna express it as the index form so that I can get rid of the ln. So now this is the new expression on the right hand side. Okay, so again, instead of writing ec prime, okay, I am going to let this ec prime be called b, another arbitrary constant, so that is easier for me to write my expression. Okay, now next, you notice that we decide to drop our modulus, and when we drop our modulus, we will change our arbitrary constant b to a. Okay, again, it doesn't matter, you want to change it to a d, that's totally fine as well. Now, but what is important is that why did we drop the mod first before substituting the given condition? Okay, if you recall from the earlier example, we already said before, you should drop the modulus first, then sub in your condition. If not, you will end up doing many extra steps, and it will be tedious and prone to error. Okay, so follow the step. If you are given a condition, always drop the modulus first, then sub in your condition. Okay, so the rest is just substitution. When t is 0, I is 2, so that you can find your arbitrary constant a. Once you have found it, the rest is just trying to make I the subject, and this is the particular solution of this question. Okay, now next part of the question, state what happened to the current of this circuit for large value of t. Okay, so there are only two variables in this question, right? The I and t. So they are asking you what happened to I, which is current, okay, when the value of t is large. T is large means t tends to infinity. What happens to I? Of course, we will need the particular solution to help us. So imagine if your t over here tends to a very large number, what happened? Then negative 3 over 4t will tends to a very negative uh, number, a very negative number like negative infinity. Okay, then what happened to e to the power of negative infinity? Tends to 0. Okay, and that explains why when t is large, okay, means t tends to infinity, our e to the power of negative 3t over 4 will tends to 0. Okay, and since we have found the expression for I, okay, this would mean that your I will tends to 2 over 3. Okay, so the current approaches 2 over 3 for large values of t.